Okay, we're solving another scholarship calculus questions from 2012, and this time we've got a collection of parallel chords connected pairs of points. So a parallel chord connected to of pairs of points on an ellipse is showing in the figure. So we've got those chords and the ellipse equations, general equation x squared over a squared plus y squared over b squared equal 1. We need to show that the midpoints of the chord lies on a straight line. Now for the midpoints or any points to lie on the straight line, it means that the gradient between any points, it's the same. Between any 2 points is the same for them to be lying on the straight line. So the first thing is we need to find the relationship between x and y. So the ellipse equation has x squared and y squared. So we need to find another equation which will be using the line equation as y equal mx plus c. So now as we have y equal mx plus c, we're just going to substitute that equation in the main general ellipse equations. And the reason for that, we need to have an equation have m, which is the gradient. And so x squared equals, so we're just substituting in here, and then we're going to multiply by a squared plus times b squared, and the reason to just get rid of the denominators. So we have this equation now, expand, we keep expanding and rearranging, and that will give us the given expression below. And then we have to arrange. As we can see, we've got x squares and x. That means we've got a quadratic equation. So if we rearrange and make this equation equal to 0, and we're trying to have all the coefficients of x squared together and x, and then the constant by itself, and that will means this is the value of a, this is the value of b, and there's the value of c in the quadratic. Okay, as we know that know that the midpoint is x1 is the sum of the 2 points divided by 2. And in the quadratic equations, we know that the sum of the 2 roots it's equal negative b over a. So we're going to use the negative b over a, and we're going to substitute the values of a and the value of b. So we've got negative 2a squared cm over b squared plus a squared m squared and over 2, and that's give me the value of the midpoint. Now if we rearrange, we will have a squared cm over b squared plus a squared, negative m squared equal x. If we rearrange for c, so c will be equal b squared plus a squared m squared over negative a squared cm x. Now the next thing we will use is the line equation y equal mx plus c, and we're going to substitute instead of x the value that we found, which is the midpoint. So it's m, open bracket, it's b, it's negative a square mc over b squared plus a square m square plus c, and you can see there's a common factor c, and that will give me an equation which is y equal b square c over b squared plus a square m square. And if you rearrange that, you will end up with c equal b square plus a square m square over b square y. And as we have the two values of c now obviously equal, so you will have this equation b square y equal b square plus a square m square over negative a square m x. And if you rearrange that equation here, so the best way is you divide both equations. You divide both equations by b squared plus a square m square. As you can see, it's the same denominator. We're trying to simplify it in here, and that will give me 1 over negative a square m x equal 1 over b square y. And you keep rearranging by multiply making common denominators, so you will multiply everything here by negative a square m b square and rearrange, make it equal to 0, so you will end up with b square x plus a square my equals 0, which is a line equation. So all the midpoints will lie into one line equation that relate to the b and a of an ellipse.